Good morning, everyone. My name is Arshia Arif. I am from Department of Mechatronics Engineering, National University of Sciences and Technology, Pakistan. The title of our paper that I am going to present is Analysis of Rule-Based and Shallow Statistical Models for COVID-19 Cough Detection for a Preliminary Diagnosis. So let's start with a brief introduction. Coronavirus has caused the COVID-19, which has spread all over the world now. It has mobilized the researchers in the areas such as pre-screening solutions, contact tracing, vaccine development, and crowd estimation. Researchers and scientists are working to aid the medical professionals in the process of testing, analyzing, control, and curing the disease. There are more than 350 PCR COVID-19 testing kits commercially available as a pre-diagnosis tool. These testing kits have their own pros and cons. Despite their commendable performance, some drawbacks of these kits are that they are not free of cost, procedure is laborious, results are time-taking, false negative diagnosis, and it is uncomfortable for the patient. A mobile application as a pre-diagnosis test can be a better approach in some aspects. For example, it is readily available and free of cost for all the users. Most common symptoms of COVID-19 disease include cough, fever, and fatigue. In case of high severity of disease, it is necessary to diagnose the disease at an early stage and start the medication timely. Cough of a person can be a useful source for identification of virus. For diagnosis using cough voices, the major requirement is abundance of data. Few studies have been carried out up till now which have used audio signals for cough events for the cross detection of disease. In a study of 2020, a dataset called NOCO-CODA for COVID has been collected and used to declare the fact that majority of COVID coughs patrons are more inclined towards the wet coughs. In another study of 2020, CNN-based audio classifier has been used to categorize COVID and non-COVID cases with a test accuracy of 70.58%. In another research of 2020, three parallel classifiers are used to process the data. DTL-MC, CML-MC, and DTL-BC with the test accuracies of 92.64%, 88.76%, and 92.85% respectively. For classification of audio data, LDB, LPC, and MFCCs are some commonly used features. MFCCs have proved to be the most efficient. Few researchers have used MFCCs for audio-based cough detection. Charles Bales in his study has developed a diagnostic tool using CNN for identification of cough for three different types of diseases based on their unique MFCCs and achieved an accuracy of 90.17% for cough detection. Vipin Bansal has also used MFCCs as features for his study. In the mobile application AI for COVID, PCA has been applied to MFCCs to get the feature vector. A classification algorithm, XGBoost, has been developed to categorize the breathing patterns in COVID-19 patients using MFCC. There are three types of data-driven decision-making models that are rule-based models, shallow statistical models, and deep learning models as shown in this table. Deep learning models generally outperform the rule-based and shallow statistical models, but they require a huge amount of data. In case of COVID-19, gathering huge amount of data in short time is very challenging. Most of the reported literature on COVID detection has used deep learning models, but with limited amount of data. The aim of this study is to analyze the performance of rule-based and shallow statistical models with limited amount of cough data for COVID detection. Quantitative analysis has been carried out using rule-based and shallow statistical classifiers with MFCCs as features. Data used for this study is a blend of three datasets. First dataset has been collected using the self-developed smart cough web application. The two datasets are publicly available datasets. nococoda, and halfwit. To achieve our goal, we have adopted this approach. As described before, we have used a blend of three data sets for this research. First of all, data has been pre-processed. For noise removal from audio signals, the data has been pre-processed. Initially, the region of interest has been extracted from all the audio samples where the cuff event was significant in each signal. As the sampling frequency is different for all the data sets, so all the audio signals have been resampled to a sampling frequency of 44,100 Hz to achieve a single pattern for all. After pre-processing of data, the next step is feature extraction. MFCCs are widely used as features for audio signals, so for all audio samples, MFCCs have been acquired using Audio Toolbox in MATLAB. The figure shows the flow diagram for extraction of MFCCs. In the beginning, speech signal is passed through a pre-emphasis filter to flatten the signal spectrally. Then the pre-emphasized signal is segmented into short frames with small overlaps to ensure the stationarity. To lessen the edge effect caused by the segmenting the data, a Hamming window is applied to each frame. The signal is then passed through the FFT block to achieve the frequency spectrum, which is then filtered through the filter band. The centers of all the frames are equally spaced in the Mel scale. Conversion from linear frequency domain to Mel frequency domain is done. Substrum is then calculated from the output power of the filter band. Afterwards, in the delta block, derivatives are added to get the delta coefficient. This has been done for the better performance of the system. Then we moved on towards the classification to identify the COVID-19 patients. In this research, for the purpose of extensive analysis, COVID-19 positive dry and wet cough samples are segregated. It has been proven in the research of Noel Kohoda that COVID-19 coughs mostly correlate with wet coughs rather than dry coughs. This claim was based on a graph plotted using two features, number of peaks and power ratio, as shown in this figure. We have also calculated these two features for our data and acquired the plots. Three combinations of data have been used for this research. Initially, we only used self-collected data using SmartCuff app. Due to lack of COVID-19 positive samples in our dataset, positive cuff samples from other two publicly available datasets have been used. Combination 2 consists of both wet and dry COVID positive samples, whereas combination 3 includes only the wet samples. We have then applied various classification techniques, including pre-LBA, logistic regression, naive Bayes, ensemble, neural network, and SVM for all the three combinations. Now let's move towards the results. This table reports the cross-validation accuracy required for all the classifiers trained for self-collected data only. The model with the highest accuracy, that is the neural network, was selected and tested. Test accuracy using a neural network came out to be 55%. For further analysis, dry COVID cough samples are discarded from the combined dataset by segregating the wet and dry samples as already discussed. In these figures, the red color indicates the wet samples and the blue color indicates the dry samples. Cross-validation accuracies for combination 2 and 3 are shown in this table. And the models with the highest cross-validation accuracies are tested. For combination 2, data with dry cuff samples, accuracy of 75% is achieved for SVM. Similarly, for combination 3, that is the data without the dry samples, test accuracy of 75% has been achieved for SVM and KNN respectively. We observed from the results that even after removing the dry cuff samples from the dataset, there is slight difference in the highest validation accuracy, but no difference in test accuracy. The proposed audio-based pretest for COVID-19 disease is better than testing kits in some respects, such as the result is provided to the patient within seconds, the test is free of cost, There is no need for the patient to visit a lab for the test, and the test does not make the patient feel anxious or uneasy. For the future work on this research, there is scope for improvement in classification accuracy. This can be achieved using better pre-processing techniques. For further improvement in results, dataset can further be extended. Furthermore, a comparison between gender-based accuracy can be conducted by employing the proposed architecture on male and female cuff samples. In this era of COVID-19 outbreak, burden on the hospitals has already increased, and several problems regarding the testing kits are there. As a solution to a few of them, in this research, audio recordings of coughing individuals have been used as pre-diagnosis for COVID-19 detection. An extensive analysis has been performed using multiple classifiers for data containing dry cough samples and the one without dry cough samples. Test accuracies for both the datasets have been achieved to be 75%. COVID-19 testing using cough samples can be advantageous for clinical diagnostic systems as well as for the patient. This research can be a step forward for a better pre-screening of COVID-19. I thank you all.